All right, this is on page 1124 in your book. If you want to screenshot it from your book, great. If you want to take a picture of the screen, great. But today's the day I'm going to teach you about the log button on your calculator. If you have a TI graphing calculator, the button can be found right next to the 7. But today's the day I'm going to teach you about the log button. Okay? All of this is really saying is that the log button means log base 10. We just don't write the 10. Okay? So this button here means log base 10. Okay? We just don't write the 10 because we live in a base 10 world. It's the one we use the most. And today's the day where we're going to really get into what the purpose of logarithms really is. I know we've played around with it, we've written them in different forms, but today you're going to see kind of the power of the logarithm, if you will. Now, if you remember, a log is a power. So, for example, you typed in log 100. It's saying, what power do you raise 10 to equal 100? So if you type in log 100, do that. You should get 2. Do you? Okay. Did you get 2? Yeah, good. Okay. Again, a log is a power. But the log button on your calculator just means what power are we raising 10 to equal whatever. Okay. So that's what we're mostly going to be working on today, all right? Now, you're going to have some free points on your quiz, like literally free. It just requires you pressing buttons, and you don't have to show any work at all. So here are 2 examples, okay? The directions are going to say round to the nearest 10,000. How many places is that? 4. That is 4 decimal places. So for logarithms, we always round to 4 places, okay? So I want you to go through and just figure out what log 7 is and log 1/2 is. Just do that straight on your calculator and write down your answers, please. Go. Before I put the answers up, and I'm sure you did it correctly, but let's think through this a little bit, right? 10 to what power equals 7? That's what we're really doing, right? So 10 to the first is 10. So we should expect that this number will be less than 1. 10 to the first power. Is this less than 1? It is. Now, we talked about this when we looked at change of base before, when we have a regular number and a fraction. Well, I have a 10 as a base here, and I have a fraction here. So when that happens, we would expect there to have negatives. So we do, okay? So for the first one, 0.8451, and for the second one, negative 0.3010. We need the 0 because that indicates that we approximated. Raise your hand if you had that. Any questions about that? Those represent powers. The power that I raised 10 to get 7. Or the power that I raised 10 to get 1/2. Okay? Those will be free points on your test or your quiz on, so you guys take it on Thursday, and then you should just don't forget your calculator. All right, let's move on to what we really use logarithms for, okay, and why they're important. So we use them to solve exponential equations. We have solved some exponential equations this year. We've already done that. We did that in 7.2. But in 7.2, we had a very specific strategy. Our whole goal was to get the bases to be the same, and then we set the powers equal to each other. Well, that doesn't always work. You can't always make the bases the same. In 7.2, they were very specific with the kinds of problems that you were given. All the problems allowed you to get the bases to be the same. But the truth is, that's a rare situation. And when you're trying to solve exponential equations, most of the time, you can't get the bases to be the same. And after today, you'll probably choose not to get the bases to be the same anymore unless the directions specifically tell you to do that. Because we can solve equations without ever changing the base now, okay? And so here are the kind of example that I'm talking about. All right, 3 to the x equals 15. Now first off, don't you dare tell me 5. Okay, x is a power. It's not 3 times 5. Okay, that's a common thing. Kids are like, oh, I'll just go right to it. It's 5. Cool. No, 3 to the 5th is not 15. Okay. Now, I also can't turn 15 into 3 to some power. Not very easily anyway. Okay, it's going to have a bunch of decimal places. Not going to work out. So this is something I want you to add to your notes of what I'm about to say, because I didn't actually write it down. What we do in situations like this is we take the log of both sides. I would write that down if I were you. Take the log of both sides. So that's what it would kind of look like. Now, when I take the log, when I have a log of an exponent, like we do over here, what happens to this power? It goes in front, right? Our power property tells us it goes in front. So we took the x that was a power and we made it a regular number now. Well, this means x times log of 3. So how do I get the x by itself? Divide by log of 3. Go back here. So I would divide this side by log of 3 and this side by log of 3. And then these cancel out. Remember, log of 3 is just some number. We just typed it in our calculator. It's just some crazy decimal. All right? So I have a crazy decimal times x equals some other probably crazy decimal. Well, we don't want to estimate those things yet. We want to put this in our calculator. Now, here's the thing that you have to watch out for. On your calculator, it automatically gives you the left parenthesis, correct? Mm-hmm. In a problem like this, you want to be sure, if you don't enter it in as a fraction, that you close this parenthesis.
Would you get an error?
No, you would get a different number. Okay? And so, because if you write it out sort of horizontally, you have to close it before you do the division.
But what is it if you don't close it?
You'll get the wrong answer. You'll get the wrong number. So what it would be doing, here, this would be wrong. So I'll write this out. What you would be doing is you'd be taking the log of 15. If you didn't close it and then you just did the division, it would take the log of that. Which these two, those of you who are staring going, well, there's no difference. Yeah, it's taking the log of all of this instead of taking the log of that and the log of that. So please, 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 please close the parentheses. Okay? And then you can do a quick little check. You should be able to figure out what x should be near, right? My original problem was 3 to the x equals 15. Well, we know that 3 squared is what? 9. Okay? 3 to the third is what? 27. So 3 squared is 9. 3 to the third is 27. 15 is in between 9 and 27. So x should be between 2 and 3. All right? So if you get something down here because you forgot to close the parenthesis and it's not between 2 and 3, there you know you made a mistake. Okay? Correct. All right. So anyway, the work ends up being like this, 2.4650. Raise your hand if you got that. Okay? So that makes sense. Should make sense to us. 3 squared is 9, so it's got to be bigger than 9 because it's 15. So it means it's got to be bigger than 2, but it's not going to be bigger than 3 because 3 to the third is 27. So it makes sense, should make sense that it's between 2 and 3. Okay, questions? Try this one yourself. Go. So, here's the work that you should have gotten. 2.0860. How many had that? Raise your hand. Good. Okay, any questions about that? Nope. All right, let's move on to another part of this section. And then we're going to actually come back to this problem in a little bit. I'll explain why in a second. It's on page 1128 in your book. You can screenshot it from there. You can take a picture. I changed what's in the book a little bit. I like mine better. So go ahead and get that in. This is the change of base formula. Change of base formula. This is going to make a big chunk of our problems that we did in 7.5 irrelevant. Let's focus down at the example. This is giving us our restrictions. A and B can't equal 1. The rest of the numbers have to be positive. Here's what I want to focus on. We had problems in 7.5 where they said approximate using the values that you were given, blah, 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 right? This renders that obsolete. Because when I have a log and a number to a different base where it doesn't come out evenly, I can rewrite that as log 11 over log 3. These two things are going to be equal to each other, okay? Notice that the base for our logarithm goes on the bottom. It's always on the bottom. Just make sure to keep that straight. And if we type that in our calculator, we would get the answer for this. So all those problems where you're trying to figure out how can I make 48 out of 6 and 8 and then add them together and practice those properties, like we don't ever have to do that again. When it comes to numbers, like I said to you guys when we were going over the examples or the answers, it was the equations where we're trying to solve for x that really where those properties are going to come into play. All right, so here's an example of a problem that we're going to have. So go ahead and get that down, and then we'll talk through what we need to do. This problem, and problems like this, every year, on the quiz, on the test, I have kids that end up having issues and losing half the points because they don't read the directions, right? There are two things being asked of you here. First off, you are being asked to express it in terms of common logarithms. That means use the change of base formula. That's what you're being told there. Use the change of base formula to express it in terms of common logarithms. That is the first thing you have to do. The second thing you have to do is then find the answer. Every year, I have kids that just find the answer and don't do this part. And you lose half the points on a really easy problem. Okay? So please pay attention. Read the directions. How would I express log base 3 of 20 using the change of base formula? What would it be? Yeah, log 20 over log 3. Okay? So that is the first part. You just got half the points for the problem. All right. Now go ahead and find the answer. Go. Do it if you haven't already. Again, let's think about this a little bit. Right? 3 to what power equals 20? That's what we're trying to figure out. We're figuring out the power that we need to raise 3 to equal 20. Well, we already know 3 to the third is 27. So it's going to have to be less than 3. But it's going to be bigger than 2 because 3 squared is 9. So it should be between 2 and 3, which it is. 2.7268. How many had that? Okay. No, you put it in, you use log 20 divided by log 3. Yeah. So you just put this in your calculator. And that's where that will come from. Okay? Questions on that? Now, as promised, I want to revisit this problem. Because I'm going to give you some options now. All right? When we first started working with logarithms, in 7.3, all we did is we went back and forth. We're like, here's a problem in exponential form, write it in logarithmic form. Here's a problem in logarithmic form, write it in exponential form. Okay? So this problem is in exponential form. So let's rewrite this in logarithmic notation, logarithmic form, if you will. Let's change that. Okay. We just took a test on doing stuff like that. There are a bunch of problems that were super easy, free points, right? Log is a power, so x is going to be equal to what?
Log 642.
Log base 6 of 42, like that. Okay. Now, we know how to solve this. We didn't 10 minutes ago, but we know how to solve it now, right? I could just rewrite this in common logs. Log 42 over log 6. And that would give me my x. Well, on the other page when we did that problem, we ended up getting the same thing a different way, right? We took the log of both sides. And eventually we landed here. Here I wrote it in logarithmic form, and then we rewrote it using common logs. I get the same thing, and eventually we get the same number, okay? My point is, I don't care which way you do it. Now that we know how to change the base formula, okay, you can get it this way. Maybe some of you will think this is easier than doing this. Here's the one thing I will tell you. In your homework today, there's going to be some problems that have powers on both sides. There's going to be some problems where the powers will have the same variable, but it might say a +1 or a -1 or -3. My recommendation to you is to not use this for ones like that. When you have powers on both sides and variables in both powers, I would use this method instead, okay? And those are trickier problems, and those are ones they're gonna be like head scratchers for you a little bit, and I expect that we'll talk about it some tomorrow, okay? Questions about this?